Today's honors geometry lesson is on proving triangles congruent, Chapter 3, Section 2. Our objectives for today are to learn and apply 3 postulates to prove triangles congruent. If you know that 2 triangles are congruent, you can conclude that the 6 parts of one triangle are congruent to the 6 parts of the other triangle. The following postulates give you 3 different ways to show that triangles are congruent by comparing 3 pairs of corresponding parts. The first postulate, which is the side-side-side postulate, or SSS for short, states if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. As you can see, triangle ABC is congruent to triangle DEF because AB is congruent to DE, BC is congruent to EF, and CA is congruent to FD. So if you were to take triangle ABC and slide it to the right and fit the vertices together on triangle DEF, you would see that not only are the sides congruent, but so are the angles. Before we move on to the next 2 postulates, sometimes it's helpful to describe the parts of a triangle in terms of their relative positions. So here again we have triangle ABC, and we can see that segment AB is opposite angle C. We know that segment AB is included between angle A and angle B, which means that it's in between, so AB is in between angles A and B. We also know that angle A is opposite segment BC, and also that angle A is included between segment AB and segment AC. So again, angle A is in between segments AB and segments AC. Knowing this, we have 2 additional postulates. We have the side angle side postulate, again for short, SAS. This states if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. And the last postulate that we're going to talk about today is the angle side angle postulate, or ASA for short. If 2 angles and the included side of one triangle are congruent to 2 angles and the included side of another triangle, then the triangles are congruent. Let's go ahead and look at example 1. For each pair of triangles, complete the congruency statement, and if the triangles cannot be proven congruent, write none. So in the first diagram, we have triangle ABC and triangle DEF. We know that angle A is congruent to angle E, side AC is congruent to side EF, and angle C is congruent to angle F. So we have a side that's included between 2 angles, so we can say based on angle side angle that triangle ABC is congruent to triangle EDF. So triangle EDF. With the second example, we again have triangle ABC and triangle ACD. We know that angle BAC is congruent to angle DCA. We also know that side AB is congruent to side CD. We also know that both triangles share side AC. So based on that reflexive property, we now know that we have an angle included between 2 sides. So we can now say that triangle ABC is congruent by side angle side, and that ABC is congruent to triangle CDA. In the next example, we have triangle ABC and triangle DEF. We know that angle B and angle E are included or in between 2 sides that are congruent. So we can now say based on side angle side that triangle ABC is congruent to triangle FED. So triangle FED. With the last example, and this is a little tricky, so if you look at triangle ABC, you can see you have 2 sides that are congruent to each other with an angle that is included, so in between those 2 sides. However, if you look at the last triangle, DEF, you can see you have 2 congruent sides, but the angle is not included. So on triangle ABC, you could set up side angle side with that angle included, but if you try to do the same thing for the other triangle, what you're going to notice is your side, but your angle is not in between those 2 sides. And since SSA is not a way to prove triangles congruent, we're going to write none because we cannot prove that ABC is congruent to the other triangle. Let's go ahead and look at example 2. And you're going to see this as a proof. So we're given that side AB, or segment AB, is parallel to segment DE, and that segment AB is also congruent to segment DE. So what I'm going to do is mark my diagram. So AB is parallel, remember we indicate that with an arrow, to DE, and also that AB is congruent to DE. So in our proof, we're going to start with our given statement. So we're going to state that AB is parallel to DE and that segment AB is congruent to segment DE based on given. Now, when we're trying to figure out these proofs, we want to prove one of the three postulates that we just learned. So we want to prove that three sides in one triangle are congruent to three sides in the other. We want to prove that an angle included between two sides are also congruent to another triangle that's an angle included in two sides. And the last one is our angle-side angle. So we want to prove that two angles and an included side are congruent to another triangle that has two angles and an included side. So the next thing we can conclude is we have angle A. So we can now say angle A is congruent to angle D. Here's A and D based on alternate interior angles. So I'm going to abbreviate alternate interior angles. We can also tell that angle B is congruent to angle E. Those are also alternate interior angles. So now if you look, you can see I have two angles with an included side in one triangle and two angles and an included side in the second triangle. So now I can say that triangle ABC is congruent to triangle DEC based on the angle-side angle postulate. And what I forgot to do here is to actually write alternate interior angles for step 3. We're going to do one more proof before we end the lesson. So again, we're given a given statement and we're going to try to prove two triangles congruent. So we're given that C is the midpoint of BD and that AB is congruent to AD. So I'm going to mark that AB is congruent to AD. And then I'm going to start working through my given statement. So I know that C is the midpoint of BD and AB is congruent to AD based on given. Because C is the midpoint of BD, I can now say that BC is congruent to DC based on the definition of a midpoint. So I'm going to write definition of midpoint. And then I'm also going to mark in my diagram that BC is congruent to CD. The other thing I'm going to notice is that AC must be congruent to itself based on that reflexive property. We're going to want to make sure we actually write property. And we're going to mark our diagram. So now we can see that triangle ABC is congruent to triangle ADC based on side, side, side. So side, side, side postulate. Okay, this is the end of our lesson. So for next class, I want you to go ahead and if you have any questions, watch the lesson again. And after watching the lesson for a second time, if you still have questions, write down your questions and see me in the next class.